my name is Jordan Gibson. This is Bio 450, 451, supervised by Dr. Saeed, and this is annealing effects of multilayered TiO2 thin film by Sol-Gel method. So the background is, what is TiO2? Well, TiO2 is the combination of transition metals and non-metals, and this material is very interesting because of the optical, electronic, and anti-reflection coating application. So this material can be used in our everyday lives, like our cell phones and our computers, and it also can be used to in sunscreen to protect the skin against ultraviolet radiation. So there are many advantages of TiO2, like optical properties, refractive index of 2.3, and it has a cubic structure. So Sol-Gel method is a great technique because it is very cost efficient and that it creates good quality film. Okay, so the materials that we used were titanium isoperoxide, absolute alcohol, hydrochloric acid, DI water, magnetic stirrer, hot plate, glass substrate, and some other materials that we used. Some of the instruments that we used in the lab were the hot plate, the ultrasonic cleaner, the spin coater, and the magnetic stirrer. So before we actually started making the film, we had to cut and clean the substrate to prevent any contamination. So we cleaned the substrate with acetone for 15 minutes, ethanol for 15 minutes, and DI water for 15 minutes using the ultrasonic cleaner. So the Sol-Gel process. So basically we use three solutions, which is titanium isoperoxide, absolute alcohol, and we use hydrochloric acid. And basically we mix all three solutions with the magnetic stirrer for 2 hours. And once that was done, then our solvent solution was ready. And this right here is the prepared solvent solution. So this was like the end result of what we got after using the magnetic stirrer for 2 hours. And this is the spin coating process. So first we put the clean substrate on the spin coater, and then we had to spin 0.2 milliliters of the solvent solution onto the substrate, and we did the first layer. So after the first layer, we waited 15 minutes, and then we added the second layer to it. So in total we did 7 samples, and they were all heated at different temperatures. Like sample 1 was as deposited, sample 2 was 50 degrees Celsius, sample 3 was 75 degrees Celsius, sample 4 was 104 degrees Celsius, sample 5 was 136 degrees Celsius, and sample 6 was 176 degrees Celsius, and sample 7 was 200 degrees Celsius. So this is the experimental setup. So we have 4 components, which is the air compressor, the fluid dispenser, fluid holder, and the spin coater. So basically this is just like a diagram of how things went. So this area is the spin coater, then this is the glass substrate, then the first layer was dispensed, and after 15 minutes the second layer was dispensed. So this is the finished product of our multi-layer titanium dioxide thin film. And these are all the different temperatures that it did. So these is the experimental results. So the FTIR measurement, this is basically telling us that TiO2 is present, and the intensity of titanium dioxide increased at 200 degrees Celsius, which means that the higher annealing temperature improved the quality of the film. So this is the Raman scattering measurement, and since the lines are at 520, this indicates the crystalline structure. It is also proving that the higher annealing temperature has a better structural property than the as deposited film. This is the XRD measurement, and this measurement is telling us the structural properties by looking at the peak location and the peak intensity. So the 111 plane is the first layer, and the 110 plane is the second layer. So as a result, we got that the higher annealing temperature made the quality of the thin film get better. So this is the SEM measurement, which is the scanning electronic microscopic. Okay, so this basically is the top view of the TiO2 thin film. So the first one is the acid powder, and you can see that it's cracking and that the surface is kind of rough. And then the 200, the annealing temperature, you can see it more as like a smooth surface, homogeneous type, and then it's crack free. So in conclusion is that the higher quality, homogeneous, crack-free surface of TiO2 thin film was successfully prepared, and at higher annealing temperature, 200 degrees Celsius, showing the highest crystallinity compared to as deposited film. And my future plans are to investigate the research project more, like using the electrical and optical properties. And the acknowledgements are Dr. Saeed, Dr. Hamada, Dr. Richardson, Dr. Painter, Dr. Harris, and D'Anthony White. And here are my 3 references that I got. And are there any questions?